All right, we will finish chapter 9 today as we talk about section 9.5. Sometimes statistics, believe it or not, do not give you the answer to every question you have. Today we're going to look at a classic example of where statistics can describe the situation but can't give us a reason, cannot give us an answer to the problem before us. This goes back to the origins of the three-strike rule. The three-strike rule basically said that if a criminal committed 3 strikes, on the 3rd strike, they would be committed to prison for life. It all started June of 1992 in Fresno, California. Purse snatching incident going horribly wrong. Kimber Reynolds shot in the head with a .357 Magnum handgun. She died the next day. Her distraught father organized a community movement to go for a 3-strike rule and take care of supposedly the criminals such as murdered his daughter. And so, basically, the law stated on the 2nd criminal conviction, the criminal would serve double. On the 3rd, 25 years to life. 2 years later, became a statewide referendum, was approved by 72% of the California voters, signed into law. Other states and governments around the world, many would eventually pass a 3-strike rule of their own. None were quite as severe as what happened in California. So what happened? What happened to the statistics? From 89 to 99, the prison population doubled. Homicide rate went down, rapes went down, robberies went down, assaults went down. So you're sitting there saying, what are you saying? The statistics prove it, doesn't it? That correlation simply does mean causation. 3-strike rule goes into effect, crime drops. The interesting thing, it seems to show that statistics do show a decrease in crime. But the same thing happened in New York City, and New York City had no 3-strike rule. This happened over the entire United States. All across the United States of America, there was a dramatic drop in crime in the late 80s, 90s. Many of them did not have a 3-strike rule. Now, before we go into that any further, I did want to mention a couple of studies that were done about criminals' behavior and a 3-strike rule. Many people think that the threat of a long jail sentence would deter crime. Criminologist Wright and Decker interviewed 86 convicted armed robbers, and they found this not to be true. You're under the influence of drug or some kind of an addiction. You need money to get your fix. You're not thinking about getting caught. And they found out that longer jail sentences really did not have that much of an effect on crime. Second argument, longer sentence would prevent crime. But we just showed you that in New York City and many other cities in the United States, crime went down and there was no 3-strike rule. The other thing that's interesting is on the 3rd crime, the average age is 43. How many crimes do 43 through 68-year-old people commit? Not that many. The vast majority of crimes are committed by men ages 16 to 32. The last thing, many criminologists feel that increased prison time just simply encourages more crime due to the damage inflicted upon people while in prison and the influences due to the people that they're incarcerated with. Okay? They get out, they've got a record, They can't get a job. They can't get housing. What are they going to do? They're going to go back to an addiction or back to getting money in somehow, some way, the way they had before that got them in trouble in the first place. 10 years later, after the three-strike went into effect, they had between 5 and 8 times as many people jailed as Canada and Western Europe did combined. We were filling the jails. I found this, I thought it was a very interesting illustration of the three-strike rule. Here's a petty criminal, Jerry Williams. 5 prior convictions, theft, parole violation, and so on. Grabbed a piece of pizza from some kids, got 25 years for a piece of pizza. Now, statistics describe this situation. The question is, what really caused that drop in crime? Because it happened in so many places where there was not a three-strike rule. What really caused it? They talk about the broken window and the ghetto syndrome in New York City. Rudy Giuliani talked about that. Increased police presence, incarceration, economic, this dramatic drop in crime in the late 80s, early 90s. What's interesting is many sociologists have a theory that they think did, in fact, cause the drop in crime, and it was not the three-strike rule. A lot of sociologists, and this is kind of a hot button issue, and I don't want to really get involved in a big argument here in this, but a lot of sociologists think the drop in crime was due to Roe v. Wade. Roe v. Wade in the United States, when abortion became legal in the early 70s, abortions guaranteed that unloved children would not be born. Say it again. Some sociologists, well, many as a matter of fact, feel that the drop in crime was because of Roe v. Wade. Unloved children were not being born. And because they were not being born, there's no way they could become a criminal. It's a very interesting proposition as to what caused the drop in crime. Notice California did scale back their three-strike rule, dropped the severe sentences only for those who were serious or violent. Pennsylvania just did it recently here a year or so ago. Delaware, states are starting to realize piling the jails full of people in the long run is not helpful. All right, very interesting. I just thought that was very interesting. Statistics do not really answer the question, and sometimes that happens. All right, so let's finish chapter 9. We talked about T-scores before when we were doing confidence intervals. You use a T-score and you do a T-test when you don't know the population standard deviation. You do precisely the same thing in hypothesis testing that we are doing in chapter 9. If you do not know sigma, if you don't know the population standard deviation, you use the sample standard deviation and you have to do a T-test. Okay, so a lot of your problems today will be doing T-tests. So let's get started. Just a few quick ones. In a right-tailed test, n is equal to 15, alpha is 0.05. Alpha, the area we don't want, is 0.05. We're going to do a T-test because we don't know the population standard deviation. So we're going to find the 0.05 column on your T-chart, find the 0.05 column and go down to, remember we take 1 off of that. We're going to go down to 14, and we go down to 14 and we get 1.761. Okay, there's our critical value. The t-value is 3.458, which is way out here. This is the do not reject region. This is the reject region. okay? We are going to reject this, all right? And how strongly are we going to reject it, okay? We would need to find the area from 3.458 to the right. So go down once again on your chart to 14. Where is 3.458? Look across on 14. Where is 3.458? Well, it's off the scale. It's way off to the right. Look at the areas at the top. Aren't the areas up here at the top getting smaller and smaller and smaller and smaller? Okay, so because 3.458 is way off, we would know that P is smaller than 0.005. Okay? P is going to be smaller than 0.005. And there's your criteria. When it is smaller than 0.005, it would be down here. There would be very, very strong evidence against H naught. And that's what we said we were going to reject. How about number 2? Number 2, we want to do a left-tailed test. We are once again doing 0.05. There are 12 taking the survey. We're going to assume normality. Go to the column with 0.05 and go down to 11. I get 1.796, but because we're on this side, due to the symmetry of the graph, it's negative 1.796 for the critical value. The t-value is negative 1.638. So we are not going to reject the null hypothesis. And what about the strength? What about the strength of our argument? We've got to find the area from negative 1.638 down. So go to your chart, go down to 11, look across. Look across here. Where is 1.638? When you go across, 1.638 is between 1.363 and 1.796. So 1.638 is going to have an area between 0.05 and 0.10. So my p-value is greater than 0.05, less than 0.10. Okay? What is happening? When you're between 0.05 and 0.10, there is only moderate evidence. We're not going to reject the null hypothesis, and that's what we said. We're not going to reject it. Finally, the two-tailed test. My old nemesis. I always forget things when I'm doing a two-tailed test. All right, here we go, two-tailed test. Two-tailed test, n is equal to 25. Alpha is 0.01. You need to cut the alpha in half to get the area of both sides. This would be 0.005 and 0.005. Okay, so we go to the 0.005 column and we go down to 24, 0.005 and down to 24. And what do I get? I get 2.797 and negative 2.797. The statistic is negative 0.895, which is over here. We are not going to reject. And we're not going to do a p-value because the criteria for your p-value is only when you're at the 5% significance level, and we're not there at all. Okay? So we are not rejecting. All right, how about this problem? Now, if you notice in this problem, nowhere in the problem does it tell you the population standard deviation, okay? Nowhere does it tell you the population standard deviation. You are going to have to do on your calculator or using the chart method, you are going to have to do the sample standard deviation. Now I've done that ahead of time. If you take all of these and add them up and divide by 12, I got that X bar is 14. I punched all the data into a calculator to get the sample standard deviation, and I got S is 5.29. Okay? Remember, if you don't have the population standard deviation, you've got to do a sample and you'd have to do a t-test. All right? So let's do it. So what we've got in this particular problem, we want to know, have preteen allowances increased? So we would have H naught. H naught is that preteens receive an average allowance of 1250. Mu equals 1250. We want to check the alternate hypothesis. Have the allowances increased? So is mu bigger than 1250? Okay, I mean, 14 is bigger than 1250, but is it statistically significantly bigger? And we're doing it at the 5% level, so we should be able to do a p-value also to get our strength of the argument. All right, so let's do the math. We've got 1250 and 14, so we would take 14 minus 1250 all over the sample standard deviation divided by the square root of 12. Okay? And even before we do that, let's draw the picture. Have they increased? Okay? It's going to be a right-tailed test. We want to go down to 11, take 1 off. We're down to 11. And at the 5% significance level, I get 1.796. Okay? All right, so let's do the math. So if I do the math here, 14 minus 1250 is 1.5 divided by parentheses 5.29 divided by the square root of 12. Sorry. And I get 0.98. Okay? I get 0.982, as a matter of fact, which is here. In the do not reject region, we are not going to reject mu equal to 1250. There's not significant evidence to say that their allowances have increased. We're going to stick with this, 1250. We're not going to reject it. What's the strength of our argument? I must find the area to the right of 0.982. So get your t-chart, go down once again, go down to 11, and try to find 0.982. And 0.982, when you're down 11, 0.982 is not even shown. It's far to the left. Look up at the areas. The areas get bigger as you go to the left. So P would have to be bigger than 0.10. P is bigger than 0.10. When you're bigger than 0.10, you have weak or no evidence. And that's what we said. We're not going to reject the null hypothesis. Okay? All right. Acid rain. We have pH level of 6. There's a new study, 15 samples. Sample mean was 6.6. It's increased. The question, at the 5% significance level, does this data show that the rain acidity is greater than 6? Okay, so H naught would be that mu is 6. We want to check the alternate, is mu greater than 6? We have to do a t-test because we know the sample standard deviation. Go down to 14 on your chart, and you want to test it at the 5% significance level. I get 1.761 again. Do the math. We have 6.6 minus 6 all over 0.672 square root of 15. Okay? Work it out. 6.6 minus 6 is 0.6 divided by, parentheses, 0.672 divided by the square root of 15, and I get 3.46, okay? And 3.46 is way over here, way over there in the reject region. We are going to reject the null hypothesis and say that rain has gotten more acidic, okay? What's the strength of our argument? This, again, was 3.46. Check your T-chart. Down to 14 again. Where is 3.46? 3.46 is off the chart to the right. 3.46 off the chart to the right. The areas get smaller up at the top. So you know that P is smaller than 0.005. P smaller than 0.005. When you're smaller even than 0.005, there's very, very strong evidence against your null hypothesis. Okay? All right. A couple more just for practice. Okay, in the following, we're going to test at the 5%. We're going to do strength of argument. I'm going to go through these rather quickly because I'm assuming you're kind of with me on this. Let's look at the first one. First one. Null hypothesis. Alternate is that it's less than 22. That's a left-tailed test. Okay? Let's try to get the critical value. At 5%, 0.05. And go down to 31. 0.05 down to 31 is 1.696, but it's on the negative side. So it should be negative 1.696. Do the math. X bar is 20 on the sample minus mu 22 all over 4 divided by root 32. You work it out. I get 20 minus 22 is negative 2 divided by, parentheses, 4 divided by the square root of 32, and I get negative 2.83. Negative 2.83, we are going to reject the null hypothesis. There's sufficient evidence to reject that, and mu should be smaller than 22. What's the strength of the argument? You need to find the area from negative 2.83 down. So go back to your T-chart. You want to go to 5% down to 31 and try to find 2.83. 2.83 is off the chart to the right. Okay? It's off the chart. The areas get smaller at the top. So P is smaller again than 0.005. Check your criteria, smaller than 0.005. Very, very strong evidence again. Now, why is that doing that? All right. Second one. Second one. We have X bar is 24. The mean was 22. Is it greater than 22? That's a right-tailed test. Right-tailed test, right here. Let's find the critical value. At 5%, go to 0.05, go down to 14. So 0.05, I'm going to go down to 14. I get 1.761. Set up the math. In that particular problem, I have 24 minus 22 all over 4 divided by root 15. 24 minus 22 is 2 divided by parentheses 4 divided by square root of 15. Close parentheses. I get 1.94. 1.94 is over there. There should be sufficient evidence to reject the null hypothesis. What is the strength of the argument? Once again, take your T-chart. You must find the area from 1.94? Yeah. We must find the area from 1.94 over. So go down to 14 again. 1.94. You can see that 1.94 is between 1.761 and 2.145. So P must be greater than 0.025, less than 0.05. How about the strength of that argument? Now, doggone it. How about the strength of that argument? If I'm in between 0.025 and 0.05, I'm right in here. There is strong evidence against H0. Not very strong, just strong evidence to get 1.94 in between 0.025 and 0.05. I've got one more. If I don't quit doing this, it's going to drive me crazy. All right. Okay, last one. Two-tailed test, because we want to know, is the mean no longer equal to 22? Could be bigger, could be smaller. So it's a two-tailed test. Because we're at the 5% significance level, alpha, the area you don't want is 0.05. You've got to cut it in half. Is 0.025. Go down the column to 23. 0.025 at 23 is 2.069, negative 2.069 for your critical value. Are you with me? Okay, let's set it up. X bar is 23 minus 22 all over 4 divided by root 24. Do the math. 23 minus 22 is 1 divided by parentheses 4 divided by square root of 24 equals, I get 1.22. So I have 1.22. Okay? So I have 1.22. I am in the do not reject region. Okay? I'm not going to reject. Mu is going to stay 22. I don't think it's different. There's not enough statistical evidence to say that we can reject this. How about the strength of the argument? Once again, it's a two-tailed test, so you got to be careful. You got to find the area from there over. So you go back down to 23 and try to find 1.22. 1.22 is not shown. 1.22 is way to the left. Way to the left. Okay, and we know the areas get bigger. So we know the p-value is greater than 0.10 if you're to the left. But hold everything. It's a two-tailed test that we cut in half at the beginning. You've got double this at the end. So it should be p is greater than 0.20. How about the criteria? Bigger than 0.20, for heaven's sakes. Bigger than 0.10 is weak or no evidence. Bigger than 0.20 is weak or no evidence. All right, homework problems. I've got a couple of extra problems here, margin of error, confidence interval, and so on to remind you of those. And here are the book problems, okay? Don't forget down here on a probability plot, That is where you get the number of data items. You find the number of normal data items in the back of the book, and you plot those points and see if they form a straight line. If you have any difficulty with this, either email Isla or email myself or give me a call during office hours, okay? And we can talk about that. And that, folks, should finish up chapter 9.